Hello, I'm Zoe Cho. In this video, I'll be using GeoZebra 3D graphing calculator to complete the 4 tasks in Tech Demo 1. So I will walk you through uh, I will walk you through all of the steps for graphing a line, a plane, a cylinder, and the ellipsis that is their intersection. Let's get started. So first task. So we are required to graph the line that has 1 and 1 and 1, the vector direction, and then the point. So here we're gonna I will enter the command line. It's because I have to let the zebra know, like, I'm trying to draw a line on the in the 3D space. So I put the line and the point from 1 and 1 and 1. Then we can see the black line here. It probably intersect it will intersect x-axis at 10, x equal 10. Let me show you that by changing the max and the minimum. Then, oh, maybe I can make it 11. Then we can see it intersect at 10, x equal 10. And then let me show you, like, 360 degree. If we look at from the 2D, it's gonna be like this downward downward line intersecting at the 10 equal x equal 10. But this one is the 3D perspective. From the bottom, it shows like that. All right. If you just put like this with the comment saying line, the GeoGebra is just gonna automatically create the parametric line in the 3D space. And then for the second task, we're gonna graph the plane 2x plus y minus 2 and z equal to, like, here is the green space which correspond to this equation. For the GeoGebra, even though you just put the equation with the 3 variables, they still recognize it as a plane and display it very correctly. But if you're using another calculator like Calplot, you probably you're required to solve for z, like 0.5 2x plus y minus 2, which is exactly the same thing actually, but we are just required to solve for z for the other calculator rather than GeoGebra. But we are just just left it here because we are gonna use this equation for the task 4. But let's make this one invisible, and then let me show you guys how it looks like from different perspective. So it's the 3D plane. And then if you see from the bottom, it shows like this. Then if I want to make a 2D, it can be shown like this. From the top, it's just a 2D. Oh, it's kind of hard. All right. All right. Problem solved. And for the second one, it looks like this. And For the task 3, let's make this invisible. For the task 3, we are gonna graph the cylinder that has radius 3. We're just gonna put the equation as it is. We don't need to do anything. Okay. So in the 2D, if it was a 2D graph, it would have been just a circle having the radius 3. But in the 3D space, we can see it is an infinite cylinder because we didn't put the boundary, the axis boundary. So anyway, it shows. Let's make it yellow. Oh, that's so scary. Okay. The yellow cylinder has the radius 3. We can see it from the bottom and from the side. All right. This one is this this describe a vertical cylinder along the z-axis. So it also renders it as the 3D surface. Finally, we are gonna graph the ellipsis that is the intersection of these two surfaces, which is the plane, which are the plane and the cylinder. Like what we have to do here is first we have to get the x and y values from the cylinder equation. We can get the x and y value, which is like x equal to square root of 3 and square root of 3 cosine of t, and the y value is equal to square root of 3 and sine of t. And then we're gonna plug the values into this equation to get the z. Then it's gonna be our ellipsis equation. So I enter the full common, like we have to say the curve so that it's gonna notice it. That's the calculator will notice it's gonna be a curve for ellipses. So the x value was 3 square root of 3 cosine of t and 3 square root of 3 and sine of t. And then here's our z value, 2.5, and then we plug the x value in here. It's gonna make this 2 and square root of 3 cosine of t plus our y value, which was square root of 3 and sine of t minus 2. For the zebra, you have to put, after all of the values, x, y, z value, you have to put the variable and its start and the end, which is 2 pi. Then we can see the black ring, which is the ellipsis. Here we can see ellipsis shape. It's the black line from the bottom. It looks like this. In the 3D space, 2D space, it will look like just a curved line, a curve, yeah. Okay. And then we have to show that this ellipsis is an actual intersection for both, like of those, by make it visible and invisible. So first we're gonna make the cylinder visible. So we can see like the ellipse is actually surrounding it intersect the cylinder. We can see from the side, from the bottom is kind of hard to see, but I think it's pretty easy to see from the side. Okay. So it actually the ellipse is actually an intersection of the cylinder. And if you look at the plane, so if you look at from the top, it looks like this kind of hard to see if it really intersect or not. So the simplest way and easiest way is just looking at those from the side. So we can exactly see like they're really the ellipsis is on the plane, which means like it intersect the plane too. So from the other side, it's like let me make it clear. Okay, there you go. It looks like a line, which means it intersects exactly on the plane. And then if we make the cylinder 2 here, it shows like this. It's also easy to see like the ellipses actually intersect both. Uh, like if you look at that from the side. All right, by looking at the many different perspective, we ensure that we show that like that ellipse is actually an intersection of the plane and the cylinder. So the that's all for this tech demo. All right. Oh good. Thank you for watching.